Welcome. On this channel, we're building a toy MMO learning exercise called Space Captain. You can find more details about it in the show notes. In this video, I think we've finally gotten to the end of trying to write the requirements document for the first version, which is here. I am going to take a scan through it, and then we're going to ask all three of the agents to turn it into a work plan. And then we're going to let each of the agents digest all three of the work plans and then update their own work plans, is my plan here. So I'm gonna skim through the whole thing here. I've done this a couple of times, so I'm gonna go pretty fast. I'm just looking for, like, if a change happened that I didn't catch. So the goals: scalable, multi-threaded, efficient networking, 2D space combat, CLI and curses interface, robust server authoritative, highly parallel state management system. Core infrastructure. Clients only receive targeted state updates, ePOL-based event loop, dynamic worker pool for parallel messages and logging. Game world and coordinates, 2D, blah, blah, blah. Distributed game loop and state management. The game loop is distributed concept. Each worker runs its own update loop at a fixed 4 kilohertz. This loop uses a batched input processing model. Phased tick cycle. The worker's main loop is divided into strict sequences of phases to manage concurrency and enable safe, consistent state snapshots for operations like rebalancing. Synchronization. Workers wait for a start of tick signal. This acts as a barrier, ensuring all workers begin the tick simultaneously. Input processing. Each worker drains its dedicated lock-free message queue, processing all client messages received since the last tick. Game state update. The worker simulates physics updates, entity positions, and resolves combat for all entities under its state management. State broadcast preparation. The worker determines the necessary state updates for each client it owns. Message dispatch. The prepared messages are in-queued to the global outbound queue. Sleep. Workers calculate. Okay. Entity identification. The server is responsible for generating a unique, persistent entity ID for each client upon successful connection. This ID is used, per ship state. All data is managed exclusively by its own worker thread. The core state for each ship includes client state synchronizations. For each client, the server tracks server state and acknowledged. For each client, the server tracks server state and acknowledged state. And I think I'm going to call this true state. We'll just leave it as server state for now. The state broadcasts with an area of interest for this version. The SIFs will send a state update to each client. This update includes the full state of the client's entities, spatial partitioning, the game world, discretized into a grid. So this is all, none of that's changed recently. Interworking 8, none of that's changed. None of that has changed. We probably maybe should consider updating that, but truthfully, it just ends up kind of being the way to do it would be to think through all the commands that a client would send. I think that's actually there. I do have one more step that I need to do here. We're going to try and define all the supported messages that a client would need to be able to send to do space combat. Server. Well, given that, I think we're on a change of course here. I don't think that I want to do the full review here. I think we just want to jump over and try and solve that problem. So read PRD's version 0.1.0. And then we're going to try and enumerate all the messages that the client and server would need to send to simulate space combat as defined in the document. So mostly the file's read. It's probably, let's see what it does. The PRDC is the client acknowledges receipt of sending back the full state, blah, blah, blah. This is inefficient. Let's assume the client will send back a sequence number of the state it received, and the server will use that to update the acknowledged state. Let's also add a message C file, file to hold message type to string function. Given that, please do the following. Okay. So, okay, so that's good. Okay. Is that every state update sent to the client has a serial ID. If any state update messages arrive out of order, or arrive out of order, messages are ignored unless they are unless they have a greater serial ID than previously received. In the future, okay. Now we'll put the diff in. We'll receive. When state updates are made, a diff is sent between the server state and the acknowledged state. When an ACK is sent, it contains the entire client state and is used to update the acknowledged that's really, really bad, obviously, because they can lie to us, so we can't do it. When the state updates are made, a diff is sent between the server state and the acknowledged state. When a state updates are made, the diff is sent. Okay, so I just realized that I can't rely on them to send back the message. I can't use that information because then they can change our states. So create a new message C, update message H with all the message types we've discussed, implement the message type to string function, update the message to include, update the makefile to include makesay in the build. This idiot doesn't, what is the file? Okay. read the read this file. It had that wrong. We're not updating the make file for anything. Make to verify. I will define a clear. Okay. Okay, we're just discarding this. Let's start with Claude. Read the PRDs. Oh, let's fix this first. Rename the PRDs folder to PRD. It's bugging me because I keep referring to the PRDs specifically. Yep. Okay, so the thing I need to do is, I know how I'll ask it. I want to get away from the network loop, get rid of away from all of the technical part. I just wanted to think about the game combat. So for consistency with common naming conventions, like there is one for that. Maybe there is, I don't know. Okay. Read the PRD version 0.1.0. Then let's try and enumerate all the message types that the client and server will need to send to each other. For example, they will need to send they need to send updates about target positions and velocities. They need to indicate changes to any dial, to any of changes to the setting of any of the ship characteristics, like shields, weapons, cloak, shields, weapons, cloak, shield, weapon, and drive. They need to indicate changes in hull integrity, and maybe other things. They may need to convey information during the DTLS handshake. Let's try and enumerate all needed messages and a rough design for their structure. Let's see what we get. Okay, so I originally started this video thinking that I was going to jump into the actually building out the work plan, but it turns out this is a missing piece that was kind of obvious that I should have done. Base message header, type version length sequence, client message, speed shields weapons cloak, type def struct, set heading message. So that's a header. This is power dials messages. That's okay. Type def struct, changing the heading. Type def struct, message header, state update, echo entire received data. Server messages, assign entity ID, human readable. Okay, so type def UN connect reject with a human readable reason. Type def own ship state. Other entities in, so we get an entity count, an array of these. All multi-byte values use network byte order, big endian. TTLS provides encryption authentication. Okay, so the thing, I had it in my head a second ago, the thing that I want to do here is, the thing that I want to do is, let's assume that the client does not send the full state back in an ACK. How does the server does the server have to track all sent messages and clear them only when an ACK is received? So the reason I put that in there to have the client send back the message in the ACK is because then you could just set it to you could take that value, set it in the ACT, as the ACT value, and you didn't have to maintain, but I think we're going to have to maintain a stack of all sent messages to the client and pop them off until you get to the on sending state data, client sent next sequence ++, client last sent current, send state on receiving ACT, client last ACT sequence, client last ACT. No history needed since full state is sent every tick. It's cheating. Assume that we will be sending diffs and not full state every tick. How do we track the history of sent messages so that we can set the acknowledged state when we get an ACK for so it was optimizing it for me, but the whole plan was at this stage to do everything like we were sending diffs, but to actually have the diff algorithm just always send the full state. This hybrid approach sends diffs normally, falls back to the state if the client is too far behind, doesn't need to store history, simple to implement and implement it reasonabout. Okay. For a diff-based system, you need to track sent diffs to reconstruct the acknowledged state. Here are two approaches. Snapshot plus diff history. Track periodic snapshots, and a bound history of diffs. Snapshots at regular intervals, every 10 seconds. 10 sequences. Circular buffer for recent diffs. Okay, I definitely last acknowledged sequence when receiving an ACK. If ACK is for our snapshot, use it directly. Otherwise, reconstruct by applying the diffs from snapshot. Oh, okay, so yes, store all the diffs, just reapply up to that serial ID. Otherwise, compressed state history. Track complete states, but compress them. Hourly or delta compressed. Type diff, ring buffer of recent states. Keep the last 4 seconds at 4 Hertz. Recommended hybrid approach. For production, I'd recommend current server state for this client, type diff struct game state. Last acknowledged state, pending diff accumulator, accumulates changes since last ACK. Fallback, periodic full state. I like it. On state change, I mean, it leaves a lot. On state change, apply, accumulate diff, sync current, on sending update, on ACK. Claude gets the credit this time. Gemini went off and La La Land there. I also didn't give him the exact same prompt. So I really, really like the control you have with Claude. It seems to just work better as an agent in terms of understanding when you want to change things. I like to use Gemini for pure research, where I know I'm not changing anything and I never ask it to. For each client, the server tracks current state. And then I'm going to do one more update to it. I'm going to make sure it acknowledges that that we use a dummy computation for the diff calculation, and it's always it always considers everything changed. I was just wondering in my head if the version 0.1.0 is getting too ambitious, too many things, but I don't think so. Okay, update the PRD, the 0.1.0 PRD to indicate that the state diff calculation will be a dummy calculation in this release. It will always indicate that all client fields need to be sent updated. Okay. I think that's okay, so I have figured that out. Like, when you want to do a placeholder algorithm like this, it is better to more or less say, hey, we're doing the whole thing, and then come back in afterwards and say, okay, make that a placeholder. I've had a hard time getting it to consider that a placeholder thing. Like you'd seen in the beginning of this, it realized that I wasn't doing anything, and it eliminated, it just totally eliminated the need for it, and then worked its way around it. But I think we're getting really close. Okay, I've successfully updated read PRD version 0, 0. We're going to do a little proof check and look for here we go. We're going to go with the vague. Just look for bad ideas. Oh, but it's going to figure it out, I think. Yeah. Yeah, it figured it out. It figured out I moved it. Okay, so we can read this. The document is largely consistent, presents a strong technical vision. The primary areas for concern are not outright bad ideas, but rather points of significant technical challenge and potentially ambiguity that could cause problems during implementation. My key points of potential issues. Conflict. This document specifies DTLS 1.3, but as of my last update, embed TLS's stable release have full support for, it's still considered experimental. Committing to, okay, recommended. So that was a nice little find that I wouldn't have. Okay. So I'm going to do these changes over here so I don't lose track. Update the PRD for 0.1.0 to specify DTLS 1.2 or 2.1. What the hell is the version? 1.2. Okay, so we'll let that one run in the background. Thousands of concurrent connections versus success criteria ambiguity. The document repeatedly phrases thousands as a high-level goal, but the specific success criteria, I'm not going to address that. I want this implementation to give me some idea of where we're sitting in terms of performance before I start to specify numbers, but minimum is for sure has to be multiple thousands. Actually, I will update it. What I'll do is in the success criteria, dummy diff implementation. Potential issue. The plan to have the dummy diff implementation that sends the full state is a reasonable short-term shortcut. However, this directly conflicts with the goal of no, piss off. That's it. Hilbert curve rebalancing, high complexity. Nah, not really. This is a core feature, so it's not a bad idea, but the implementation risk is high. I would suggest ensuring that the development plan allocates significant time to it. Client-side prediction, missing feature. The document doesn't mention client-side prediction. The game will feel very sluggish and respond. Yeah, you don't understand. Even a simple form of client-side continuing to move. Okay. It's right. We'll let this, okay. Reread the PRD, the 0.1.0 PRD, and then add client, we'll just copy paste. Predict ship positions. Nope. So I'm going to clear before I do this. Git commit, and we want to do it for Claude and Gemini. Oops. Git commit Claude Gemini, and then I want to have. How did I originally ask that over here? I'm going to ask the exact same question over here. Okay, see, it's just not nearly as good of a tool. Hey, it just doesn't exist. Did I actually... you idiot. I told you what file to look for, and you're looking for the wrong one. Because I told you to look for that file. Oh. So that it knows the PRD's directory was changed to PRD. I think that's what's going on. Otherwise, why would it keep looking in the wrong spot? Yep. And now I want to... Now, is this waiting on me again? Yes. Now, let's see if I can find the right damn folder. Okay, and I actually, yeah. I wish they all prompted the same way. One wants a yes, one wants you to pick the thing with the dot, and the other one wants a 1, 2, 3. I don't care which one, pick a common one. Okay, recommendation, UDP reliability layer detail, but document clearly future, but document, hold it. Let's back up here. There's more here, so. Strengths and positives, clear scope, methodical, good logging, spatial partitioning, strengths, network details, claim, concern, suggestion, clearly detail or specify a reference to how many packet sequencing, retransmission, acknowledgement, window sizing, timeout strategies, blah, blah, blah. I don't think so. Consider a lower tick interval that you don't understand. Spatial partitioning, consider clarifying the reasoning behind choosing 128 by 100. It doesn't matter. It's going to get resized. Claim, diff implementation, suggestion, document explicitly the future improvements will include diff logic optimized to detect change. It's kind of it's implied. Clearly communicated plan or roadmap for better respawn methods without disconnecting. Document explicitly evaluated precision limits and clarify future plans for mitigation, coordinate normalization, conflicts check. No internal contradictions. Recommendation, proceed, but document clearly spatial partitioning to grade. Okay, so it didn't find anything that I want to change. And based on the changes, I can see you've updated the proposed commit message. And yes. Now, one last thing is I want to take this message and give it to Claude and see what it says. Read the PRD version 1 and look for any obvious conflicts or bad ideas. It was moseying. Yeah, it's honking now, so it was moseying a second ago. I seen that. Burning tokens. After analyzing, I've identified several. Does it really still have custom? So what does it say here? Custom. So we're going to search for that. Vim PRD version 1. It's viewing an old version. So read. So let's clear. See if it gives the same thing, burning tokens again. We are done here. I wish that I have CC usage for Claude. I wish I had a good way of getting the session tokens from Codex, but I do not. Requests 51. So 1,300 or 13,000 or 1,362,000. I cannot read. 1.3 million is what I wanted to say. Output tokens 20. Okay. Major issue. Thousands of clients target conflicts with Claude MD. The PRD targets thousands of concurrent connections, but Claude state server must handle update Claude.md to indicate thousands of concurrent connections. Protocol mismatch. The PRD describes DTL secured, but the current implementation uses. Yep, that's known. We're going to throw it away. Architecture conflicts. The PRD describes spatial partitioning, but the current doesn't matter. Overly complex. Yeah, it is. Thank you. Features like DTL, certificate pinning, and Hilbert curve and double buffer partition maps seem excessive for an initial release. No, they don't. My thinking of this is the thing I'm trying to figure out if it even can be done right is can I use an agent to do that very complex thing? I feel like it would be very hard to iteratively add them in if there wasn't a plan on how to add them in. Performance requirements. It doesn't understand. Missing current feature. Doesn't mention any of those, and those don't matter anymore. So the only thing we want to do is update Claude here. And everything else is good to go. We're going to push it. How can it hasn't been read yet? How can it tell me that there's a mismatch if it hasn't read it? Done. Yep. Woohoo! I think we've gotten to the point of next really is. We still got to read through this thing again and make sure. But I do believe that next step really is building the plan, the work plan. I have previously built the work plan like 4 or 5, 6 videos back. And that particular plan ended up being like 13 or 14 phases with 60 or nearly 60 steps. It only got bigger. So it's going to be a pretty healthy work plan. So I think that I will see you in the next video.